All right, so in this question, we are asked to determine if the following salt is neutral, acidic, or basic. And if it is acidic or basic, we're supposed to write the appropriate equilibrium equation for the acid or base that exists when the salt is dissolved in aqueous solution. And if it's neutral, we'll write only NR for no reaction. So the important skill to have here begins with knowing what's going to happen to this ionic compound. Now this is just the one we're given. It could be one of many different salts. This salt, sodium cyanide, when I put it in water, when you dissolve it in water, it breaks apart into its component ions. And one of those ions is the sodium ion, and then the other one is Cn-, the cyanide ion. Okay? All right, so now what you have to do is you have to look at each one of these ions, and you don't know where they came from, but let's just imagine that each one came from an acid or a base. And so if this sodium ion did come from a base, and the cation will always come from a base, or you should imagine that the cation always comes from a base, what base did it come from? Well, the base that I know that has sodium in it, just a very common one, would be sodium hydroxide. And that is a strong base. Now because of that, the rule is that anything that comes from a strong acid or a strong base will not go on to react with the water at all. So this will have no reaction. Okay, that sodium ion will not have any reaction with the water. Now let's think about the cyanide. So the anion will always come from an acid. The cation always comes from a base. In this exercise of imagining where these ions may have come from, the anion, the negative ion, we should imagine always comes from an acid. And so if this did come from an acid, it must have come from HCN, hydrocyanic acid. Well, is that on my list of strong acids? Nope, it's not. So that means that it is a weak acid. Okay? And so any ion that's related to a weak acid or a weak base will go on to react with the water. So this one reacts with the water. Okay? And so now we just want to describe how it reacts with the water. And so I have that ion, the Cn-, okay, and so it's aqueous, it's in solution. Well, it is the conjugate base, Cn- is the conjugate base of this weak acid. Well, I call it a conjugate base for a reason, because it can behave like a base in water. When it does so in a reversible way. And what do bases do? Bases will accept an H+. In this case, it's going to accept an H+ from the water to become HCN, okay? And that's aqueous. And then what's left over on the water is hydroxide ion, okay, because it ripped it ripped a hydrogen off of this water molecule. So we get left over with hydroxide ion. All right, so that really kind of answers the question. This is going to be a basic solution. Its pH is going to be greater than 7. And the reason why is because this ion that I generate when I put sodium cyanide into solution, I generate this ion, this cyanide ion, which is the conjugate base of the weak acid, hydrocyanic acid. So this conjugate base is going to behave like a base. And what do bases do? Well, they react with water to take off a hydrogen, and they leave behind the hydroxide ion, which is what makes it a basic solution.